Students, in this video we're going to look at time value of money. The idea here is that money decreases in value over time. So let's say you have some money today, say you had $1,000. Into the future, that money is not going to be worth as much. $1,000 is not going to be worth as much 5-10 years from now as it is today. In order for that money to be worth as much in the future as it is now, it needs to be invested in, say, a bank account or stocks or shares, and it needs to grow in size. And we can calculate that using this present value of annuity formula here. So we'll use that in part of the question we're about to do. And in this question, we have someone, Emily Hocking, who is saving so that she'll have funds for a housing deposit in 5 years' time. All right, now, part A of this involves using an annuity in advance because we have a regular payment here. Now, you've studied these recently, so perhaps you want to pause the video at this stage and see if you can calculate part A on your own using the annuity in advance formula, and then I'll have a go at it. Okay, I'm going to try it now. So using the annuity in advance formula, we'll put the information in. So the regular payment is $320. The interest rate 0.065 over 26 because it's fortnightly. And it's a rather long formula. I'll just keep going with it. 130 periods because 5 years fortnightly, so 5 by 26 is 130. And that all goes over the interest rate per period. Okay, so if we put that into the calculator, we get this. Once again, a rather long formula. It'll take me a little while. Oops. Nearly there. And so that's how much Emily Hocking will have saved up by the end. $49,206. And if we ran that to the nearest cent, 80 cents. Oops, just got those the wrong way around. I'll fix that up. $206.80. Okay, so there is the total savings after 5 years. Okay, so before this even happens, we can calculate what the present value of the savings is using this formula over here. Okay, so the present value of the savings is equal to the final value over 1 plus I to the n. Now, you've seen this formula in a previous video where we were rearranging the compound interest formula. So it's really just a rearrangement of that formula. And this is going to tell us how much is this $49,206 worth today before Emily even starts saving. Okay, so let's put that information in. The final value is the $49,206.80. And we just use the conditions or the interest rate and time period from the investment. So it's like, how much would we need to invest in order for it to grow to this amount into the future? So if we put this into the calculator, 49,206.80 0.065 26. Okay, and we get 35,567.68. Okay, so what's that mean? It's pretty much what we're asked in part C. What it's saying or showing us is that, you know, in the future, this $49,206, all right, that we have, if we the present value, the value of that money at the moment is this much, 35,567.68. All right, so if you had this much money today, 35,567.68, you need it to grow to 49,206.80 in the future to be worth the same amount. All right. So I'm going to explain this meaning in terms of investments for Emily. Now, what we see here is that if, in order to have the same amount in the future, Emily would need to invest this much. So Emily would need to invest 35,567.68 into this account in order for it to grow to the 49,206.80 in 5 years' time. So essentially what we're saying is the value, the amount of money today is this much, the 35,000 and a bit, and in the future that would need to be, it would need to grow to 49,206 to have the same value. All right, go ahead and try some of these time value of money questions. Thanks for watching.